Now let's look at the end behavior. One of them is real natural feeling and the other feels a little bit weird. Meanwhile, I'm going to do to the right first. I think it's just a lot easier. So I don't want to go way to the right. What happens with this function? Well, if x is a very big positive number, squaring it gives an even bigger positive number. When a is positive and I multiply by a huge number, I get a huge number. The ln of a huge number is also huge positive. I get positive huge times positive huge. We get positive huge. And just remember how to interpret this. This says way to the right, right? The y values on the graph go way up. All right. Now let's do way left. This is not way left. Let me write this down first. lim x arrow minus infinity x squared ln of ax. Now why is that not far left? Because this function isn't defined way to the left. In fact, it's not defined whenever x is less than 0. So what happens here is that we're not going to go to minus infinity. We have to go as far left as this graph can actually go, and that's really just to the right of 0. And so we have to see what's going on here. If x is a tiny positive number, squared is actually a tinier positive number. If I plug in a tiny positive number and try to take the ln of it, just remember what the graph of ln looks like. It looks like that, right? We're talking about y values that are way down here. That's negative infinity. Now, what is 0 times minus infinity? Well, that's a limit of the form that we call indeterminate. We saw in class that that means it could actually be anything. It does mean that the only way we're going to be able to do this is using Newton's method, not Newton's method, L'Hopital's rule, which means I have to rewrite this as a fraction. So first thing I want to do is rewrite this as a fraction and then see what happens. How am I going to rewrite this as a fraction? I'm going to rewrite it like this, which of course doesn't help at all. Then I'm going to multiply the top by 1 over x squared. And I'm going to multiply the bottom by 1 over x squared. So what I'm going to get is the limit. X goes to 0 plus. I have just the ln of ax on top. On the bottom I have 1 over x squared, but I am going to use L'Hopital's rule, so I'm going to write it as a power function, so it's easy to take the derivative. Now the top goes to negative infinity. The bottom goes to positive infinity. So we get to use L'Hopital's rule. Remember, when you use L'Hopital's rule, you have to show that thing on top, show that thing on bottom, and tell everybody you're using L'Hopital's rule. Now, how does L'Hopital's rule work? It says show you can do it, then take the derivative of the top, which is 1 over ax times a, take the derivative of the bottom, which is minus 2, x to the minus 3, and then try taking the limit all over again. Now this is kind of a mess. We could try to plug in. What I would prefer to do is just multiply the top and the bottom by x cubed. So top by x cubed, bottom by x cubed. And what that's going to give me over here is a limit. X goes to 0 plus. All I get on top is x squared. All I get on bottom is minus 2. And remember, the first thing we're supposed to do when we try to evaluate a new limit is plug in, and I plug in, and I get 0. It's very, 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 very interesting. In the final step, what we're going to do is to find the intercepts and then put the graph together.